So yesterday we did the derivatives of sine and cosine. Today we're going to do the last main function, last primary trig ratio, which is the tangent function, tan of x. Tan of x is a little bit weird, so and you'll see that its derivative is also a little bit weird. So again, just to recap, don't worry about the straight lines. Sine goes through the origin, goes through 0, 0. This is sine of x. It's an odd function. Cosine of x does not go through the origin. Cosine of x is just sine of x moved 90 degrees to the left. 90 degrees is also pi over 2 radians. So cosine of x goes through 0, 1. Y-intercept does not go through the origin. The main parent function anyways, you can always do transformations on these. So this one in red is cosine of x. Both sine and cosine, they have max of positive 1. So the maximum value is 1, and the minimum value is negative 1. Their period is going to be 360 degrees, which in radians is 2 pi radians. So these are very similar. Tan, on the other hand, is weird. Because when you think of tan, what is tan? Where does it come from? Tan is, well, it's opposite over the adjacent using the triangle. But another ratio that we can use for tan is sine of x over cosine of x. And where does this come from? It comes from the fact that if you take this ratio and if you divide both the numerator and the denominator by the hypotenuse of the triangle, you'll see that you're allowed to cancel these out. So you can always go back to this. So if you just divide them, you'll see that this is sine of x and this is cosine of x. So that's where the ratio comes from. Now the graph of tan of x is a little bit weird because there are some values where cosine of x is going to be 0. If you look at the red curve here, we're looking at the y values of cosine of x, okay? The y values of cosine of x. Where are they 0? Right here. This is at pi over 2 or 90 degrees. This is 180, and this is 270. You'll see that the red curve is going to be, it's going to have a y value of 0, which means at these points, you will end up dividing by 0 because the value of cosine of x is a 0. Can you divide by 0?
No.
No, you cannot. So what ends up happening is that at these points, and again, this is going to go on forever, at 90 and 270, because you have a 0 in the denominator, you end up getting an asymptote like this. So at 90, 270, and every 180 degrees, in fact, there's going to be an asymptote every 180 degrees. And you can plug values in a calculator, or you can get the values of sine of x and cosine of x. And when you plot it out, tan of x is going to look like this. So it's not a continuous function. It is still a periodic function. Periodic means it repeats every certain degrees, but it is not continuous like sine or cosine because there are some values where the denominator will be a 0. So that's point number one. Point number two is that if you look at the graph of tan of x, does it have a maximum or a minimum? It's going to ride the asymptotes forever. So what does that mean?
Mm-hmm. It doesn't.
There is no max, there is no min. Max is infinity, min is negative infinity. It's going to go on forever. And if you look at the period, that also changes. Before it was 360 degrees, but now if you take from here to here, the period is only 180 degrees or pi radians. So tan is a little bit different compared to sine and cosine, which means the derivative is also going to be different. Now let's try and come up with y prime for tan of x. So if y is tan of x, the question is what's y prime? And we can do this using everything we've done. It's not that difficult. So step number one, we're going to change tan into something that we can work with. Well, we don't know the derivative for tan, but we do know the derivative for sine. We do know the derivative of cosine, and tan is ultimately sine x over cosine of x. So let's work with this. This is going to be our y. Using that, we're going to find y prime. Do you use the product rule or the quotient rule here?
The quotient rule.
So this is going to be your f. This is going to be your g. Quotient rule says it's very similar to product rule, except there's a minus instead of a plus. And you also have to divide it by g squared, not g prime squared, the original g squared. So what's f prime? If f is sine of x, what's f prime?
Cosine of x.
Cosine of x. So you have cosine of x times g as it is, which is cosine as it is, minus f as it is, so sine of x, times, what's g prime?
Negative sine of x.
Negative sine of x, all over the original g squared, which is cosine of x whole squared. Sometimes this is also written as cos squared of x. They mean the same thing. And we can simplify this a little bit. Cosine x times cosine x is like saying a times a. It's going to be a squared. This becomes a plus negative, and this negative, you can bring this here, becomes a plus. Sine times sine is sine squared, all over cosine squared x. Now, there's a fundamental identity in trigonometry which says cosine x squared plus sine x squared is always going to be 1. This is always going to be 1. So you can replace the numerator with 1. We did this in trig identities. The proof of this is the fact that when you draw a triangle, here, let's draw a triangle here quickly. See that why that's true. I'm going to draw the 30-60 triangle, which looks like this. So this is some angle theta. Actually, we know what the angle is. It's 30. I just said it. So this is 30, which means this is 60. 30-60 triangle works like this. 1, 2, root 3. This is one of the special triangles. The other one is 45-45. So now if you look at this triangle, what's sine of 30? Sine is opposite over the hypotenuse, right? So what will be sine of 30?
1/2.
1 over 2. What about cosine of 30?
It's root of 3/2.
Root 3 over 2. Right, now let's use this idea. So if we do sine 30 whole squared plus cosine 30 whole squared, you're going to get 1 over 4. 1 over 2 squared is 1 over 4. Plus, what's root 3 over 2 squared? It's 3 over 4, right? You square this, and this cancels out. So you get a 3 in the numerator, and 2 squared is 4. So you end up getting 4 over 4, which is a 1. You can also
Mhm.
do this without having any numbers. So let's say you have sine x whole squared plus cosine x whole squared. Sine is the opposite over hypotenuse. Cosine x is the adjacent over hypotenuse. So you get o squared plus a squared over h squared, right? And this is Pythagorean theorem, if you remember. C squared is always a squared plus b squared. Same idea here. The hypotenuse is going to be your c. That's always going to be the adjacent squared plus the opposite squared. So you end up getting h squared over h squared, which is a 1. So that's where this identity comes from. Cosine squared x plus sine squared x or sine squared x plus cosine squared x is always going to be 1. So we can replace that with a 1, and then we get 1 over cosine squared x. What is the reciprocal function of cosine? So there are 3 secondary ratios, right? So you have sine, cosine, and tan. These are the primary ratios. If you flip them upside down like this, 1 over sine x, you'll get the secondary ratio. It's called cosecant x, written CSC. Cosecant. That is the reciprocal of sine. 1 over cosine is called secant, S-E-C-X. And tangent, 1 over tan, the reciprocal, also called the secondary trig ratio, is called cotangent, C-O-T, is how we write it. So 1 over cosine squared, if you look at this, cosine is secant, the reciprocal, if you flip it upside down. So when you flip cosine squared upside down, you'll get secant squared x. And that is the derivative of tan x. Cool?
Mm-hmm.
So it's a lot of information here, but most of this is just review. The only new part here is that the derivative of tan is secant squared x. So not as easy as sine or cosine. Once you know that, everything else is the same. You're going to use your product rule, chain rule, whatever applies. And remember, outside function takes priority. It's always the bigger picture first. So here, what do you think y prime is, knowing that the derivative of tan is sec squared? It's going to be secant squared, or sec tan becomes secant squared, right?
Mm-hmm.
The angle does not change. And then you have to use the chain rule. What do we multiply this by?
2x plus 3.
And we're done. And remember, you can never multiply these two together because there is an invisible bracket here. This is your angle, right?
Mm-hmm.
And this is just something at the end. You cannot multiply your angle with anything. Even if this was just a number, you are not allowed to multiply them. Now for this next one, again, the concept is the same. The outer function, which in this case is power 4, that's going to be our main function. Everything inside is going to be a chain rule component. So what's y prime here?
You bring the 4 down.
You bring the 4 down, so it becomes a 3, and then,
Then you do cosine of x.
yeah. What about the last component? What's the derivative of tan?
Secant squared.
Secant squared. That's it. End of story. Done. One step. It's not that difficult. Once you know that tan becomes secant squared, it's just whatever. Most of these are going to be one steps. This one, you have to use product rule because you're multiplying a linear function with a trig function. So you can say this is f, and you can say this entire thing is g. And remember, product rule is f prime g plus f g prime. So what's y prime here?
It's 1.
It's 1, yeah. And then you multiply g as it is, so you can even ignore the 1. I'm just going to write tan 2x minus 1 plus x as it is. What's the derivative of, what's g prime here?
It's secant squared. And then times 2.
And that's it, we're done. The only cleanup you could possibly do is maybe move this 2 in the front here, over here. And that's it. That's as far as you can go. Cool?
Mm-hmm.
You cannot take this common. Remember, these are angles. You cannot pull them out. And that's it. That's tan. Easy peasy. Um, yeah, let's do a couple of these for practice. And all of them are honestly pretty simple. It's gonna be one step for all of them. So here, for the top one, what will be the derivative?
You bring the 2 down.
Bring the 2 down. Everything inside stays exactly the same. The 2 becomes a 1. And then the chain rule component, what do we multiply that by?
Secant squared.
Secant squared x. And what's the derivative of cosine?
Negative sine x.
Negative sine x. Done. Okay, what about e?
Do we use the product rule?
What do you think? Do you have two different functions being multiplied? The answer is yes. Um, let's use product rule. There's another dumb way of doing this, which I'll show you in a second. But for now, let's use product rule. So it's going to be f prime, right? This is your f, this is your g. So what's f prime?
Does the 3 go in front?
Yes. Remember this, sine cube x means sine x whole cubed.
Mm-hmm.
Whereas sine x cubed means only the angle is being cubed, not the function. So let me show you the derivative for both of them. The derivative of this is the one that applies here. It's going to be 3 sine squared x times cosine of x, because sine x is the chain rule component. And then you multiply g as it is, plus sine cube x times secant squared x. And that's the final answer for E. And then it's easy as that. But the derivative of this, look at this. The derivative of this would be cosine x cubed times 3x squared. And that's the difference. The derivative of this is this guy. What is the derivative of this? Is this guy. Here's another way you can do this, which is, I mean, it's always helpful to know multiple ways, but it's less efficient. What you do is you change y. Okay, this is not y prime, this is still y. I'm just rewriting tan as this, and then you can use, this is still y. And then you can use quotient rule to find the derivative of this, which will look like this. 4 sine cubed x times cosine x times cosine x. So this is f prime minus sine 4x times negative sine, which will make this a plus, and all over cosine squared x. There you go. That's another way you can apply derivatives to this problem. And when you do trig identities is essentially they will give you something and they'll ask you to either prove this or not prove this. You need to know how to go about doing it both ways. It's just pure algebra at the end of the day, but you need to know how to go do it both ways. But this is not as clean as the other one because now we have introduced a denominator, but it is correct. Let's look at the last one. Pretty simple as well. What's y prime for f?
It's itself.
It's itself, yeah. And then what do we multiply this by? And there is a chain rule component.
With secant squared of root of x
Yeah. Anything else?
times 1 over 2x to the power of negative 1 over 2.
Yeah, there we go. And that's it. That's the answer. It's still a one step, but you just have to use the chain rule twice because there's three functions here. 1, 2, 3. Hmm. All right, cotangent of x. Remember, what is this a reciprocal of? Something over 1 over something is cot of x. Remember, this is a secondary ratio. Cotangent, it's in the name. It's tan.
Or
If
1 over 10.
1 over 10. So if you flip tan upside down, you'll get cotangent of x. I'm going to show you how to do this two ways. So first of all, we're going to replace this cotan with 1 over tan. That's one approach. The other approach, remember, cotan is tan flipped upside down. So if tan is sine over cos, what do you think cotangent is in terms of sine and cos?
Cos over sine.
Cos over sine, right? So there's two ways, and you have to use quotient rule for both of them. So again, here this is going to be f, this is going to be g. Here this is going to be f, this is going to be g. So let's work with this one, y prime. F prime is 0. You agree?
Mm-hmm.
0 times anything is a 0, so we can ignore that. So again, it's f prime g minus f g prime over g squared. Since f prime is a 0, this entire term was going to be a 0. Minus f is 1 times g prime, the derivative of tan is sec squared, all over g squared, which is tan squared, right? Let's see if we can clean this a little bit. Um, so this is the same thing as saying negative 1 over cosine squared x, secant is 1 over cosine, divided by, and tan is sine squared over cosine squared. The cubes and the squares, they all carry on from the main ratio. So if tan is sine over cosine, tan squared would be sine squared over cos squared. Let's flip this upside down. Whenever there's a division sign, we would flip it upside down. Can we cancel out the cosine squares?
Yes.
Yes. See ya, see ya. What's 1 over sine squared? It's going to be another secondary ratio.
It's cosecant.
Yeah. So you get negative cosecant squared x, and that's the derivative of cotangent x. We can show that this is the same thing using this. F prime is negative sine x times g as it is minus f as it is times g prime, so cosine x, all over sine squared x. So you get negative sine squared x minus cosine squared x all over sine squared x. By the way, you cannot cross these out because there's a minus sign. If there was no minus sign, you could have. As of right now, you cannot. Now what? So now you need to know a little bit of algebra. The algebra is that sine squared plus cosine. This is a fundamental identity of trig. This is a 1. So you have to somehow make this look like this. What can we do to make that look like that? Notice how they both share a negative sign, negative symbol. You'll pull out negative 1. Look at
Mm-hmm.
this. So from the numerator, you'll pull out negative 1 or a negative sign. If you do that, you'll get sine squared x plus cosine squared x. When you open this bracket, you go right back to it. Over sine squared x. So this will be negative 1 over sine squared x. So that'll still be negative cosecant squared x. Cool?
Mm-hmm.
So that's the derivative of cotangent of x. It's negative cosecant x. Cosecant squared x. So we know d over dx means the derivative of cotangent of x is negative cosecant squared x. This one says find f double prime of x. It's asking you to find the second derivative. So let's go one step at a time. To find the second derivative, you first have to find the first derivative. What is the derivative of this?
It's negative cosecant squared of 4x times 4.
Yep. So that's the first derivative. You can even move that -4 up here. That part is easy. This isn't terribly difficult either. What's f double prime of x? Which means, what's the derivative of this guy? So remember, that squared applies to the cosecant. So you can write this as this. -4 cosecant squared 4x, cosecant 4x whole squared. So that is still f prime of x. What'll be the derivative of that?
You bring the 2 down.
You bring the 2 down, so it'll be -8 cosecant 4x to the power of 1 times what? So that's tricky actually because we don't know what that is. What's the derivative of cosecant? So if y is cosecant, which is the same thing as 1 over sine, right?
Mm-hmm.
Um, you can also write this as this. Let's write it as this to make our lives easier. It's the reciprocal of sine x. You can say sine x to the power of -1. So the derivative of cosecant x is going to be -1 sine x to the -2, yeah, times cosine of x. See if that made sense. 1 over sine x, it's like saying 1 over a is a to the -1, and then I just used the polynomial rule. Brought down the -1, took 1 away from it, and then multiplied it with the derivative of the bracket. So the derivative of cosecant x is going to be -1 over, again, look at this, sine x squared to the -2 goes in the denominator, becomes positive, but the cosine of x is still up top, like that. So this becomes -1 over sine squared is cosecant x squared times cos of x. There you go. That's the derivative of cosecant x. So here, the chain rule component, we have to multiply it with the derivative of the bracket, which is going to be negative cosecant squared of the angle times cosine x of the angle. So that's the chain rule component for cosecant 4x. And then finally, we have that 4x, we multiply this with a 4. And that's the final answer for this question. Did that make sense?
Mm-hmm.
So again, it's not terribly difficult, but yeah, it's a lot of it is just pure algebra, knowing that you can write this in this form. Here, let's try this. If y is secant, remember secant is the reciprocal of cosine. What's y prime? Just to help you, I'm going to write it in this form. So what's the derivative of this function?
You'll bring the -1 in the front.
Yeah? Then what?
And then cosine x
Yes.
times negative sine x.
So it's going to become -2, okay?
Mm-hmm.
Times negative sine x. So the negatives cancel out, so you get sine x times 1 over cosine squared x, make it positive. So it'll be sine x secant squared x. And that's the derivative of secant. Cool? So these are called inferred or applied derivatives. No one remembers, that this is this, but you can always come up with it by using sine, cosine. Those you have to remember. Anything else, you can always come up with it on the spot using the rules. Let's see what else we can do here. Um, let's start here. So this will be basically the review of the entire thing. We didn't touch much on curve sketching, but we'll see how that goes. Let's start with the easy ones. And again, these are pretty simple, honestly. What's y prime for a?
Itself
Itself, yeah. What do you multiply it by?
with negative 4x.
Negative 4x is right. Done. What about the second one here?
You get 2 cosine of x
Yes.
minus 3 negative sine of 5x, and that can just turn into a positive.
Mm-hmm. Anything else?
And then you multiply by 5.
Yeah. So you can pair the 5 with the 3, and you're done. Let's try this one. And remember, this cube applies to the entire function. That's the bigger picture, whereas this squared only applies to the angle. So what's going to be y prime here?
You bring the 3 in front of everything. And then cosine of x squared.
And then one last part. Remember the x squared. So you just multiply it by 2x, okay?
Mm-hmm.
Notice there's three functions here. You have the cubic function on the outside, the sine, and the squared, so you have to use the chain rule twice. What about f?
Um,
Tan becomes what?
Cosecant squared.
Yeah, so this rule doesn't apply to the tan. It only applies to the angle. So you have cosecant squared of this, right? And then you have to multiply this with the derivative of the angle. What's the derivative here?
1/2.
Yeah, right? Anything else? The answer is yes. There's one last thing you need to multiply this with. The derivative of 1 minus x, which is
Negative 1.
-1. Okay, -1. If it was 1, we wouldn't care. The derivative of 1 minus x, well, the derivative of 1 is 0. But the derivative of negative x is minus 1, so that's the important part. If it was 1 plus x, we could have completely ignored it because the derivative would have been 1. Cool?
Mm-hmm.
Done. Okay, this question looks complicated. So we have a function, 2e to the 3x, probably 2 that we can graph. Looks something like this. And this one is 6x plus 2, so that one probably looks like this. So what's the question? We are trying to find the equation of the tangent line that is parallel to this green line. Okay, so there exists a tangent line somewhere on this black curve. So there's an infinite number of tangent lines, but the one that we're interested in, okay, has to be parallel to this green line. So that's the question. So our final answer is going to be in this form, y equals mx plus b, right?
Mm-hmm.
I'll tell you this. M is already given in the question. How are parallel lines similar? What do they share?
The same slope.
The same slope. What's the slope here?
It's just 6/1.
That's just 6 over 1, so we already have the slope. Y is going to be 6x plus b. Now the only thing we don't have is that b value. How do you think we find that b value? So this is our line. To find the b value, you need to plug in a y and an x. That's the only way, right?
Mm-hmm.
So what we do is, because they have not given us an x value, we can just pick any x value, plug it into this equation to get a y value, and plug both of them here. And that will give us the b value. The easiest x value to plug in is probably 0. So let's do that. Y of 0 is going to be 2 times e to the power of 0. It's going to be 2. Yeah?
Mm-hmm.
So we have everything. So y is 2. X is 0, right?
Mm-hmm.
And that sketch is a rough sketch, so it might not align. Plus b. So b is going to be 2. And we're done. Cool.
Yep.
How are perpendicular lines related?
The slope is the negative reciprocal.
Let's see what else is looking interesting here. Let's do this one. So we're given a velocity function, and the question is asking us for the acceleration. Looks complicated, it's really not. Remember this. Position or displacement, the derivative is going to be velocity. The derivative of velocity is acceleration. So if you want to go from position to acceleration, it's going to be a second derivative. So this question, they've given us a velocity function. They're asking us for an acceleration function. What do we do? How do you get velocity from acceleration? Sorry, the other way around. How do you get acceleration from velocity?
The second derivative.
The second derivative. Actually, from velocity, you just find the first derivative.
Mm-hmm.
So in part A, they're asking us for AT, which we know is simply the derivative of the velocity function. So all we have to do is find v prime of t. So what'll that be here?
Itself.
Itself is correct. What else? Do we multiply it by anything? You see that negative k? It's like saying e to the negative 2t. What would we multiply it by? What's the chain rule component? Same idea.
So you multiplied by negative kt.
Yeah, not kt, just negative k.
Oh,
Because the
okay.
derivative of negative 2t is negative 2, same idea. Negative kt, k is a constant, so you
Mm-hmm.
multiply it by negative k. So ultimately what this is that this is just the original velocity function. So that's just v of t. We're multiplying the original function by a constant negative k. Cool?
Mm-hmm.
Um, so we're multiplying velocity by a negative number. Um, so what's actually happening to the thing? So let's say your velocity is 10. You multiply it by negative 2, you get negative 20. Now you have to think of it in terms of these four things, if you remember those. If you had 10, this is the original velocity, you ended up with negative 20. What happened to the velocity? Did it speed up or slow down?
It slowed down.
So it's weird. It's this case right here. Um, this one right here, this one. And the answer is that it's, if you look at the tangent lines here, right? Is the slope increasing or decreasing? Now you have to think of this in both dimensions. By that I mean there's four cases. It's either increasing at an increasing rate, increasing, sorry, that was ID. That's increasing, but the slopes are getting smaller and smaller. So it's increasing at a decreasing rate, increasing at an increasing rate, decreasing at an increasing rate, and decreasing at a decreasing rate. So this one, it's decreasing, right? But the rate itself is increasing. So what you say is that it's speeding in the negative direction. It's speeding up in the negative direction, okay? Because it's the tangent lines are getting more vertical in a negative direction, which means it's speeding up in the negative direction. Part B, what is the initial velocity of the particle? What about this one? Initial velocity. What does initial mean in terms of time?
0.
0. So all you have to do is find v of 0. 10 to the e negative 0, e to the power of 0 is a 1, so 10 meters per second or whatever, cm per second. Done. Part C. At what time is the velocity equal to half the initial velocity? Now what? If the initial velocity is 10, what's half of that?
It's 5.
So what we need to do is we need to find the time when the velocity function is equal to 5. In other words, we need to find t when v of t is 5. So we're going to get an exponential equation like this. How do we solve this for t? The first step is easy.
You divide by 10.
Yeah. What about the next step? How do you get rid of that e? You have to apply the inverse function on both sides. If you
So
had,
you use ln.
yeah, use ln on both sides. So ln of this is going to be equal to ln of that. These are inverse functions, and you're allowed to bring this down. So you get negative kt is equal to ln of 0.5. So your time is going to be ln of 0.5 over negative k, okay? We don't know what negative k is.
Mm-hmm.
So that is the time, and it's asking us for the acceleration. So we're simply going to plug it into the acceleration function that we have here. I'm going to replace that t with this. So the acceleration at this time is going to be 10 times e to the negative k times the time, which is ln of 0.5 over negative k times negative k. Can clean this up a bit. This and this cancels out. This and this are inverse functions. They also end up canceling out. So you get 10 times 0.5, which is 5 times negative k. So the acceleration is going to be negative 5k for the final answer for this question. Cool.
Mm-hmm.
You're allowed to cancel these things. Look at this. Ln of e to the 0.5. These two are inverse functions. They cancel each other out. And you're allowed to bring this in the front. So that entire expression there, ln of e to the 0.5, these two are being multiplied, and they are in the exponent of ln. That's 0.5. This stems from the fact that f of f inverse of x in any order, or f inverse of f of x, the inverse function and the OG function, they cancel out, and you get an x either way. Another example is like 10 to the log of x. That's always going to be x. Log to the 10 of x, that's always going to be x. Because they're inverse functions, okay?
Mm-hmm.
Calculate the slope of the tangent line. Not that difficult of a question. 5 to the x, we know what this looks like. Every exponential function, the parent function, goes through a y-intercept of 1. There's going to be a horizontal asymptote. Exponential functions cannot cross that. It's going to look like this. So at the x value of 2, what's the y value for 5x, 5 to the x? When x is 2, what's the y value?
It's 25.
It's 25. So we know that this point is 2 comma 25. What's the question asking us? The tangent line. So it's going to look like this. The tangent line is going to be in this form. Y equals mx plus b. Do you remember how to find m? How do we find the slope of that tangent line? We're interested in the slope.
Isn't it like the first derivative?
Yes, slope means the derivative. So all you have to do to find m is to find y prime at that x value. So 2, like that. M is always going to be y prime at that x value. So what's y prime for 5 to the x?
Do you multiply it with ln of 5?
Yes. So you get 5 to the x times ln of 5, and add 2, that's going to be 25 times ln of 5. So that's the slope, okay?
Mm-hmm.
And we found the x and the y value here. Well, x was given. We found the y value by just plugging it in. So for the final answer, it's going to be y equals, well, let's just replace y, m, and x to find the b value. So y is 25, m is 25 times ln of 5, x is 2 plus b, like that. So b is going to be 25 minus, I guess you can multiply these two, 50 ln 5. So that's the y-intercept. And we have everything. Let's plug it back into this. M was 25 times ln of 5 and the x. And our y-intercept was 25 minus 50 ln 5. And that's going to be the final answer. And we're done. Cool.
Mm-hmm.
It's a very common question. Slope of the tangent line. Just find y prime at that x value. Now let's try this one. Limits. These are also 10-second answers. If you see it, you see it. Otherwise, we're going to be stuck. The first one's very simple. It's asking you what's f of 2. What's the y value when the x value is 2? And you have two choices. You got to look at whether it's open circle or closed circle. You know what they mean, right?
Mm-hmm.
Open circle means exclusive, not included. Closed circle means inclusive. So what's the y value? Is it 1 or is it 3? And the x value is 2.
It's 3.
It's 3, that's correct. The limit, now limit 2 minus. Minus means you're coming at it from the left direction, right? 2 minus means you're coming at it here from this direction. It doesn't really apply to that point. So 2 minus means we're looking at it right here. What's the y value? What y value is it approaching?
1.
1. The next one, third, it's asking us for 2 plus. Now you're looking at it from the right side of 2. What's the y value?
3.
3. Now the question is, does the limit at x equals to 2 exist for f of x? Knowing that from the left it's 1, from the right it's 3. Does this exist? The
No.
answer is no, it does not exist. DNE means does not exist. You can say NA or whatever, not applicable. It does not exist because the limits on both sides have to be the same, okay?
Mm-hmm.
What about at 6? Does the limit at 6 exist? Now it's not asking us for left, right? It's just asking us for 6. See, what you can do here is you can go at it from both directions. So let's go at it from the right and let's go at it from the left. So what is it from 6 plus? What's the y value?
2.
2. What about 6 minus? What's the y value?
Also 2.
So what's the limit as exactly 6?
It's 2.
It's 2. It doesn't matter that f of 6 does not exist. F of 6, there's an open circle there. There's no y value for f of 6. But the limit, because these are called two-sided limits, from the right side and the left side, the limits are the same. The limit does exist. That's kind of hard to wrap your head around. The y value at exactly 6 does not exist, okay? We don't know what f of 6 is. It does not exist, but the limit exists. Limit means the approximate y value at that x value. And the approximate limit is going to be 2, as we can see from the left and the right sides. The
Mm-hmm.
last question there, B, what about at 4? Does the limit at 4 exist? It's the same concept. You have to look at it from the right and the left. If they're the same, it does. Otherwise, it does not. Thoughts?
Like,
Let's let's look at it
um,
from the left. Okay, let's look at it from the left. So this is called 4 minus. 4 minus, there's an asymptote, so you're looking at it over here. What is the limit? Where is it going? It's gonna ride the asymptote forever. So where's it gonna end up?
infinity,
Positive infinity. What about on the other side? 4 minus, sorry, 4 plus. From the right
negative
side of 4,
infinity.
negative infinity. Are these limits the same?
No.
No, because these limits are different. This does not exist. And the justification is the fact that the left side and the right side limits are different. Cool.
Hmm.
All right, let's call it there for today.
Okay, thank you.
See ya.